everyone, myself Mrunali Shikhare along with my teammates Pratiksha, Yadav and Vaishnavi Tilekar. We are from Department of Computer Engineering and we are presenting VIIT exam by Satkam. So the topic of our case study is a situation in an electric scooter company. The questions we are chosen are question number 2, 3, 4, 6, 7, 9, 10 and 13. The first question is what are some of the design considerations you would have for designing the storage features and what will you need to consider for security for the documents while designing the architecture. So in today's digital world, storing and accessing important documents quickly and securely is essential, especially when users and drivers are always on the move. So today I'll be presenting how we can design a document storage feature that is both easy to use and secure. This feature is meant to be help users upload documents easily from their phone while drivers can view them on a tablet anytime they need without any delay or safety issues. So the first is design considerations for document storage. Slide contents are easy upload, view on dashboard, storage limits, support formats, and fast sync. To make the feature user friendly and reliable, we focused on the five main design points. First, uploading should be simple from gallery or camera. Next, once uploaded, documents should sync instantly so the driver can see them on their dashboard. We'll also set a file size limit like 5 MB to avoid heavy uploads. Only common formats like PDF, JPG and PNG will be allowed. And finally, syncing should be fast so users and drivers always have updated files. Second is security considerations. In this, the slide contents are data encryption, access control, login protection, cloud security, and auto logout. Security is extremely important when storing personal documents. We'll use the data encryption so files are safe while uploading and storing. Only the owner of the file will have access control to view or edit the document. To protect users' accounts, we'll use login options like OTP, passport, or fingerprint. We'll store everything on trusted and secure platforms like AWS or Google Cloud. And finally, if the tablet is left idle, it will automatically log out to prevent misuse. Summary is easy to upload and view documents, file size and type are controlled, fast syncing between app and tablet, security, strong features, and cloud based and encrypted storage. So in short, our storage feature is designed to be simple, fast and secure. It supports real-time syncing, has size and format control to use powerful cloud security and encryption methods. These make it easy for users to manage their documents and give drivers quick, safe access when needed. Question number 2 is list the potential reasons for any two of the issues which the customer have complained about and write the test scenarios you would use to test and ensure they have been fixed. So customers have reported issues that affect their trust and experience when we need to understand the reasons behind these platforms and test them properly to ensure they are fixed. So in this part, I will talk about two common issues that customers have reported with the scooter and app. We'll look at why these problems may be happening and how we can test to make sure they are fixed properly. Issue 1 is sudden battery drain. Possible reasons are battery percentage may not be properly calibrated and the system doesn't predict range accurately, especially on rough roads or at high speeds. The first issue is that the scooter battery dies suddenly without giving the rider a proper warning. This could happen if the battery percentage is not accurate or if the range predictions fails during fast rides or rough terrains. Test scenarios for issue 1. First one is ride the scooter and check for battery alerts like 20%, 15%, 10% and 5%, both on the tablet and mobile app. Check if a warning sound or alert plays when battery is low during the ride. Test the scooter or uphill roads on or bumpy terrain to see if the range updates properly in real time. To fix this issue, we'll perform tests where we ride the scooter at different battery levels and ensure that alerts are shown clearly. We'll also test the scooter on rough roads to check if the battery prediction adjusts correctly and gives an accurate range. Second issue, app shows old or delayed data. The issue 2 is app shows outdated or delayed scooter data. Possible reasons would be scooter is sending data late to the cloud, app is not refreshing date on time, uh, then their cloud be server delays or sync issues. The second issue is that users often see outdated speed, battery level, or location on the app. This might be happen if the scooter isn't sending data quickly or if the app or server is slow to update. Test scenarios for issue 2. Ride the scooter, stop, check if the app updates speeds, charge, and location within 5 to 10 seconds. Simulate poor network and test if app syncs properly once internet comes back. Refresh the app multiple times to check if live data updates or remains old. Check if notifications like ride complete, low battery come through on time. So we'll test this by riding and stopping the scooter to see how quickly the app updates the data. We'll also simulate a bad network to see if the app catches up once it reconnects. Refreshing the app should always show live data and notifications should arrive without delay. So the summary of the test issue testing is first one is fixed battery warnings and range prediction with low battery alert testing. Second is fix outdated app data with speed, sync and network recovery test. Real world testing needed for rough roads, weak networks and server sync. In summary, we'll use real world test scenarios to find and fix the problems users are facing. By testing in different conditions, we can make sure that battery warnings are accurate and the app always shows fresh data. This helps us to improve both safety and customer trust. Thank you. Over to Pratiksha.
So the third question is the company would like the app to have intelligence and provide recommendations to the driver. What kind of data should the app collect from the vehicle and what kind of recommendations can be done? Is there a possibility to use ML and AI for this analysis and if so, what can be the use cases? So to begin with, let's look at the first at kind of data we should be collecting to drive real impact. We are focusing on five key areas. First one is battery data, including things like charge cycles and temperature patterns. Then second one is vehicle usage and performance, such as speed, acceleration and braking trends. Then third one is rider behavior. This captures how each user drives and their personal preferences. Then fourth one is environmental conditions like external temperature and humidity levels. And last is maintenance logs, meaning service history and the parts that have been replaced. Now, based on this rich data, we can offer users personalized recommendation. So, first one is smart charging tips. By analyzing battery data, we help extend battery life. Then, second one is range optimization. We tailor suggestions based on vehicle use and surrounding conditions. Then, third one is maintenance alerts, triggered using real time performance data and service logs. Then, fourth one is riding tips, fully customized according to individual driving behavior. And of course, detailed usage reports for better transparency and smarter decisions. Now let's explore how we can put machine learning and AI to work. First, battery health prediction. Using historical charge cycles and usage patterns, we can accurately predict battery life and recommend the best charging practices. Then, personalized ride suggestions. We can suggest the most eco-friendly or efficient driving models based on traffic, rider behavior, and road conditions. Then, third one is abnormality detection. ML models will help us catch unusual issues like battery drain or performance inconsistencies early on. And finally, a driver scoring model. This tracks driving habits like speed, energy usage, and braking to give riders helpful efficiency feedback. These use cases not only enhance the user experience but also help in predicting issues and encouraging better driving behavior. So, in summary, we are using data and AI together to make every ride smarter, safer, and more efficient, giving users real value while optimizing performance behind the scenes. So, the fourth question is, what can be the business and operational metrics and measurements the company can use for the new version of the vehicle and the goals they have for it? Let's now talk about what this means for our business. Our revenue growth goal is ambitious. We are targeting a 50% increase in just the first 6 months post launch. Market share wise, we are currently in fourth place, and our aim is to move up to second place within a year. Lastly, by using targeted, data driven strategies, we plan to significantly reduce customer acquisition cost. These goals are aggressive but absolutely achievable with the right execution. Next, on the operational front, here is what we are targeting. First one is defect rate. We want this as low as possible by ensuring the highest manufacturing quality. Second one is manufacturing lead time. By streamlining the supply chain, we aim to cut it down by 50%. Third one is on time delivery. Improving our logistics and inventory systems will help us deliver consistently. Fourth one is service response time. Our support system will be optimized for fast, effective responses. Then, battery health degradation. We are using advanced monitoring tools to ensure minimal battery wear. And finally, app performance, aiming for a crash rate below 0.5% and at least a 4.5 star rating on the app stores through regular updates. So, to wrap it all up, we are working towards rapid business growth and stronger market positioning by leveraging smart data, AI, and a solid operational foundation. This approach not only delivers value to the user but also ensures that we are building a scalable future ready solution. Then next I will handle over to Vaishnavi.
So, moving towards the question 5, use the inside out and outside in technique of releasing the product to the market and list the top 5 things you will do in inside out planning to release the new app to the market and the outside in planning for releasing the new app. Inside out planning. So, when it comes to launching a new app, we first look at it from the company side. That's the inside out approach. Our first step is to finalize the entire app architecture, how the backend, frontend, and scooter connectivity will work together. Next, we run internal tests to make sure the app and scooter communicate smoothly and the system is stable. We also train the customer support team so they are prepared to handle questions or issues from users. Then we prepare a detailed release plan to phases like beta testing and feedback collection. Finally, we create support materials, facts, help guides, and known issues so users feel guided after the app is launched. Outside in planning. Now, shifting to the outside in approach, this focuses completely on the end users. We begin by conducting beta tests with real users and collecting their feedback on usability. Then we do a competitor analysis to understand what's working in other apps and how we can do better. We make sure the user interface is clean and simple so even non-tech savvy users can navigate it easily. Next, we focus on clear marketing that communicates how this app will solve real user problems. Question 6. The company is collecting the data in the cloud already but have had performance issues to collect the data and update the app. What can be the reasons for that and what would be improved for the data integration from the vehicle to the cloud and the send the data post analysis to the app. Cloud issues part 1. This questions highlights some technical challenges in syncing vehicle data to the cloud and updating the app. The first issue is slow syncing between the scooter and the cloud. Important data like location and battery isn't updating fast enough. To fix that, we can use lightweight protocols like MQTT or WebSockets what allow faster real-time communication. Cloud issues part 2. Along with that, there is no caching system for frequently accessed data. This means the app makes a full database request every time, which slows things down. We recommend using Redis or a similar caching solution to quickly deliver a common data. Also, the app relies on conscious polling. It keeps checking the cloud for updates, which uses up bandwidth and slows everything. Question 7. Research on the evolution of the domain on electric vehicles and represent it on one side in an impactful way on what has been the evaluation and where think it will be 10 years from now, and what kind of features function would be available, how has the technology evolved, and what is the future direction of the technology. This slide explores how the electric vehicle domain has changed over the years. Before 2010s, EVs are pretty basic. They had small batteries, short ranges, and were more experimental than practical. From 2010 to 2025, we saw massive improvements, better designs, and even app integration. Government policies also supported this growth. By 2035, we expect huge advancement. Batteries will charge in under 10 minutes. Cars will be self driving using AI, and vehicles could even power your home. Question 8. What do you think are the business metrics which are being used by the company to decide what to focus on for improvements and changes? What engineering metrics and measurements do you think should be looked at considering the complaints from customers? Do also give the reasons for the metrics and measurements you have selected. Business metrics. In this question, we look at how the company can track performance and decide what to improve. Business metrics helps measure market impact, so we look at scooter sales numbers, profit per vehicles, and company's market trend. Engineering metrics. On the technical side, we focus on engineering metrics that improve product performance. Battery charging time is crucial. User expect it to drop from 6 hours to under 4. We also track battery health over time to prevent sudden drop-offs. And that brings us to the end of our presentation. Thank you so much for your time and attention.